I call this projectile motion part 2. In theory, Sam, I'm not going to show you a single new thing today. If I've done my job right, you should be anticipating where I'm going today. I hope. But you should also be saying, hey, these are tough. These are all, in my mind, most of the ones I'll be doing today, I would call B+, A-, or A-level questions. In other words, yeah, I'll tell you which ones are fair game on a test as a written and which ones are fair game on a test as a multiple choice. But this first page is kind of a summary of everything we've done so far. So I wrote here, when we launch an object into the air, we call it a projectile, sure. Projectiles travel in a parabolic trajectory. Projectiles travel in a parabola, which is one of the reasons you look at it in math. Parabolas show up in nature all over the place, and one of the easy ones is in projectiles. But it's easier to use vectors and break it down into its components, vertical and horizontal. So I wrote down here, break the following velocity vector into its vertical and horizontal components. So I would go d, 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 d. What will I call this bottom one here? Vx. And I would call this one here Vy initial. Why would I add the initial to the Vy? I want to remind myself it's the one that's changing. Vx is going to be constant because there's a horizontal acceleration. It's going to be opposite hypotenuse adjacent. You may notice that we end up with cos theta equals Vx over 24, or as I alluded to earlier, I said Vx ends up being 24 cos 36 degrees. You may notice that I end up with opposite over hypotenuse sine theta equals Vy over 24, or I think I tried to give you some dumb way to realize that Vy was sine. But there's the actual derivation when you do the cross multiply, one fraction equals one fraction. Mr. Dueck, will y always be sine? No. Will Vy always be sine? It will be in this unit because I'm always going to measure the angle from the horizontal. It would not be, Emma, if I decided to point the gun straight up and then tilt it and I gave you this angle, then all the trig stuff reverses, but I'm keeping it simple in this unit. Key ideas: horizontal motion is constant. What does that mean? That means that Ax is 0, which means this is your range equation. Instead of d equals vit plus a half at squared, Logan, you don't need to say the plus a half at squared. Woohoo! Vertical motion, Vy changes, but Ay is constant. So dy equals VIYT plus a half at squared. This means it's a quadratic. Now, if you launch horizontally, don't write this next bit down, Ty. Ty's going to put his phone out. No, you know what? He's in grade 12 and he knows me and he got caught. Something to notice, if we launch horizontally like this from a cliff, what's your initial vertical velocity? Ashley, 0, which means, don't write this down. It means you can do that and you can get the t by itself. So even though it's a quadratic, it's times by 2, divide by a square root. And that's solvable without bringing out the quadratic formula to find time. But if it isn't horizontally, you're either going to end up with a quadratic equation, use the quadratic formula, or I said your second strategy is you can find Vy final and then use that to find t without doing a quadratic. So does this mean, oh, at the top I wrote Vy is 0. Does that mean the velocity overall is 0? No, because it's still traveling horizontally. In fact, if you wanted to, Shelby, you could say at the top of every projectile, the velocity equals Vx for that split second. Also, if we start from ground level and end at ground level, Vy initial equals negative Vy final. That's handy. If you go what goes up must come down. Doesn't work on a cliff, does work on the ground. And last, if you're beginning from a vertical height, please remember that the ground is below you, and what that means is your vertical displacement is going to be negative. Example 1 says a projectile is launched from a 45-meter high cliff at an angle of 64 degrees with the horizontal and an initial velocity of 36 meters per second. Okay. I wrote here DULP, draw a little picture. There's my cliff. There's my velocity. Ryan, what's the magnitude of the velocity according to the question? Let's put a little 36 along the hypotenusy thingy here. And at what angle? So let's go d, 64 degrees. And what else have they told me? My diagrams are nothing near works of art, but what I do try and usually do is draw them big enough that I can do triangles and trig on them. In other words, I wouldn't draw something like this and think I'll solve it, because when you try drawing triangles and components, it just gets yucky. Bigger is usually better for a diagram. Ryan, did you quote me an angle? Did you give me an angle? Did you quote me an angle? Did you show me that there is an angle? Say yes. Then you know what? There's another strategy that immediately comes to mind when I see an angle. What, folks? I'm going to break this up into components. I refuse to deal with that 36 meters per second at an angle of 64 degrees. Instead, I'm going to break this up into Vx and Vy initial. Rachel, what are they asking me to find in part A?
Find the range.
What is the range? What's another, how do we express that? What is it asking, actually?
Dx.
Okay, that's dx. Let's write down next to there, Rachel, my joy, dx equals question mark, which suggests I'm going to be tackling part A horizontally somewhat. I'm not sure I left enough room here, unfortunately. We're going to have to kind of write small, but that's okay, I guess. AX equals what? Nothing. AY equals negative 9.8. Vx equals, what did we say on the previous page? Which trig function is Vx? So I'm going to go 36 cos 64. I have to save room. Normally I'd do Vx like somewhere else, but I just realized we're going to be kind of cramped for space here, so I'm trying to save lines. 36 cos 64, 15.781. Vy initial is going to be 36 sine 64. $32.357, I guess. Logan, I got two things in the horizontal column. I got two pieces of information in the vertical column. That's not enough. It's got to be something else I know. They told me that dy equals negative, whoop, I was going to say 9.8, negative 45. And now I can find t using a quadratic equation. Or I can find Vy final and then find t. Either or. Who would like me to use the quadratic formula approach and find t? 2, 1, 2, 3. Who would like me to find Vy final and then use that to find t? More of you. So those of you that do the quadratic, go ahead, work on your own. Those of you that want me to find Vy final, not going to do it. What I am going to do is allow you to do it. I'm going to freeze the screen. Let's see if we all get, so find Vy final using something. Then find T, and let's see if we get the same answer. I'll unfreeze the screen when we're done, and let's see if we end up in the same place. Yucky. That's better. Squared plus 2 times negative 9.8 for those of you following at home. Yeah, I figured I was going to run out of room. Sheesh. Note to self, Mr. Dueck, add way more room for this question. Don't have room to show work on that line. Yeesh. Let's just do it. Negative that thing minus 32.357 divided by negative 9.7. I get an answer somewhere between 6 and 9 seconds for time. I hope. I got that. I guarantee on your test there's going to be a question like this that asks you to find the range, and it's going to be cliff at an angle, so you've got to get comfy with it. We will be practicing a bunch more, but you've got to get comfy with it. Am I right? Yeah?
I got 8.38.
Okay, let me come look. You realize we're not done. Rachel, what did you say they were asking me to find? Horizontal distance. I've gone this far, I've done this much work, and I'm not even there yet. Now, unfortunately, because I really botched the spacing of this, here's going to be my little horizontal section right here. So I'm going to say dx equals, I don't know, vx equals 15.781, t equals 7.78. How can I find the range? Atla, what happened to the plus a half AT squared? Yeah, 0, okay? And normally I'd show my work more, but Mr. Dueck really needs to respace, and I will next year. So flunk this course, and this will be an entire page worth of space next year. Note to self. Vx was 15.781 times time was still stored on my calculator, thankfully, so I'll use my answer button. And we end up with a range of 123, which is what I did say in brackets there was the answer. So, woohoo! Now, that was because I gave you dy. Look up, my angels. What if instead of giving you this, what if I told you the range? What if you knew this? It gets way easier, because to find time, how would you get t by itself in this equation here? Just divide by Vx and you're done. No quadratic, no Vf squared equals Vi squared. And again, hopefully you're starting to clue in, Ryan. The key to solving these is always, give me the time of flight. Once I got that, everything kind of becomes plug and chug-ish. Complicated plug and chug, but plug and chug-ish. So if they ever give you the range, whoop, don't erase it, Mr. Dueck. Divide by Vx, get the t by itself, and then you can go walking. Now, when you walk over here, you'll be using d, if they want the height of the cliff, d equals vit plus a half at squared. The half at squared won't vanish, but you're not trying to get the quadratic by itself. It's just plug and chug. B. And Charmaine, part C is exactly number 5, like you asked me. I'm going to give you time, and I'm going to say, tell me the velocity, magnitude, and direction at a given point. So let's see. Part B says, when does the projectile reach its maximum height? Now, this is an important word right there, because the word height, what do you think? Does that imply vertical or horizontal? So how am I going to be solving this? Vertical. So I would probably just make a little note, and I would say, okay, AY equals negative 9.8, and I would say VY initial equals 32.357. They want me to find that's not enough. There must be something else that I know. Ah, this one I have to dredge out from my understanding of physics. At the top, Alex, what can you tell me about the vertical velocity? So Vy final is 0. Which means I can use the same time equation that I used earlier. T equals V final minus V initial over A. I can use Vf equals Vi plus At, get the t by itself. Wow, after all that work, this one's not so bad. 0 minus 32.357, all divided by negative 9.8. More than one number on the top brackets, 0 minus 32.357. All divided by negative 9.8. You get 3.3 seconds? Woohoo! And then it says, how high is the maximum height? What are they asking me to find there, Justice? Which one? Okay, now I'm going to be fussy. Anytime you say distance or velocity, I want to know in which area are we talking. So which distance? dy. Dy equals question mark. I have all my data listed here. So I guess, Justice, I'm looking for an equation that has dy, a, vi, t, or v final. And I have no problem if you use that, because you're a good test writer. You said, you know what, the easiest is going to be d equals vit plus a half at squared. Of course, that means I'm using t to find d, and that might mean if I got t wrong, I'll get d wrong. So I could use d equals vf squared minus vi squared all over 2a if I got it by itself correct. And I have absolutely no problem with that. What grade are we in? As far as I'm concerned, you are free to use values you already did. So although I totally applaud that, and on a test I probably would, since this is in my homework, I'm going to gamble, and I'm going to go with the shorter one that has d by itself already. I'm going to use equals vit plus a half at squared, where everything is vertical. And when I do that, I'm going to get 32.357 times 3.3 plus 0.5, negative 9.8, 3.3 squared, and I should get 98.4. VI T is my answer, so I'll use my answer button, plus a half A T. Of course, I get 9, what, Why didn't I get 98.4? Grant, what? Oh, this would be the height from the top of the cliff. Now we have to actually add the cliff. So I'm going to say dy, I'll write this number down, 53.4. And then I'll say for my final answer, height equals 53.4 plus, how high was the cliff? 40 something, 45? Ah, there is the 98.4 meters. Woohoo! C. I like question C. I like question C. Question C is a nice question. Charmaine, what does C want me to find? Okay, now velocity, here's what it wants me to find. It either wants me to find, don't write this down, the slanty velocity like that if it's on its way up, or it wants me to find the slanty velocity like that if it's on its way down. Regardless, my approach is going to be find Vx, find Vy at that time, and add them tip to tail. How will I know whether it's on its way up or whether it's on its way down? How will that tell me whether it's on its way up or on its way down? Positive or negative, okay? Normally I'd like to DOLP, but because in this case well, wait a minute. What did we find on the previous question for time to get to the top? You know what? 2.4 seconds, it's still on its way up because 3.3 is when it got to the top. So I can DOLP. If I wasn't sure, I'd hold off on drawing the picture because I wouldn't know whether it was on its way up or on its way down. But here, since I know it reached the top after 3.3, I think I can safely say what it's asking me to find is that vector v. After 2.4 seconds, it looks something like that. Maybe steeper, maybe shallower, but it is on its way up still. At an angle. At a what? I think I better go components. I'll have Vx, which I know. 15.781. And I'll have Vy final, which I don't know yet. Vy, that's vertical, so over here I'll say to myself, self Vy initial, Ay was negative 9.8. What was Vy initial? 32.357? Need more room, Mr. Dueck. 32.357. Oh, and Charmaine, in this question, I know T. They told me 2.4. Can I find Vy final? Yeah, it's going to be Vy initial plus AT, as long as everything in there is vertical, 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 except for T because it's a scalar. The vertical velocity, the vertical component, after 2.3 seconds is going to be 32.357 plus negative 9.8 times 2.4. 32.357 plus negative 9.8 times 2.4. So I can tell Logan the velocity of this projectile anywhere along its path. You give me a time, I already know Vx. I just have to find the vertical component, add them tip to tail. I get 8.837, and I'm going to label that on my, well, first of all, let's put it here. 8.837, and let's put that on my triangle. Now what? Now what? How can I find vector v? It's going to be Pythagoras, and then theta is going to be, I think, tangent again. Okay, so vector v is going to be Pythagoras. It's going to be 15.781 squared plus, hey, I still have that answer, squared, square root. I get a magnitude of 18.1 meters per second at, let's go find tan theta equals 8.837 all over 15.781. $29. North of east? Oh, no. I said, I'll live with that. If you say that, I won't freak out. But we said, you know what? Since technically that's up and that's down, not north and south, because we're looking from the side view, I called this above the horizontal. Is that okay, Charmaine? And I think that'll help you with number 5 on the previous exercise as well. Hey, let's turn the page. This one drives me crazy because everyone knows it now, but on the test, everyone forgets. What if I launch horizontally? What can you tell me about Vy initial? 0. But every time I give a horizontal projectile, about 1/5 of my kids, because they don't like a 0, they put the horizontal velocity in there, and I've seen it happen in the homework too. Don't do the easy fix, but of course that dominoes through the rest of your question. See, 906, I'm going to number 3, and then I think I'm going to run into a wall. Yeah, okay. Just checking how much more I want to get done. Number 3, cliff at an angle. It says this: a projectile is launched from a cliff as shown. It lands on the ground 5.2 seconds later. Holy smokes! They gave me time. You know what that means, Ryan? I think this is going to be a lot less difficult. I hope. Okay. Sam, what do they want me to find in part A? Height. Do you think that's vertical or horizontal? Okay. But I can't start with that 20. Why not? Do you see an angle? So what should my first instinct be with that slanty velocity? What am I going to do, folks? Okay, so we got our strategy here. Let's component it. How much room did I leave? Whole page? Holy schmoly. Change colors, Mr. Dueck. Opposite, hypotenuse, adjacent. Vx ends up being cos. Of course it does. Vy initial ends up being 20 sine 30. That one I can do in my head. It's going to be 10. 20 cos 30. Well, I know cos 30 is 0.866. So if it was a 10, it'd be 8.66. So it's a 20 double at 16, 17.32. Yeah. I have cos 30 and sine. In grade 12, you'll probably end up memorizing sine 30 and cos 30 because they show up so often. Let me double check. Was I right? Yeah, there you go. So, Ashley, I know sine 30. That's a no-brainer. I've learned that one. Cos 30, I actually know is 0.866. So I times it by 10 to get 8.66. To times it by 20, I just doubled it. So 8 plus 8 is 0.6 plus 0.6 is 1.2. There's 17.2. 0.06 add a 12 to that 0.2, and there's your 32. Thank you very much. You've been a good audience. Tip your waitress. Okay, is right. Oh, A. Sam said vertical. Sam, I know that part C, I'm going to need lots of room, and you've had me, you notice I'm normally a fan of working down. We're going to work across this time because I need lots of space. So I'm going to say, okay, vertical, AY is negative 9.8. VY initial is 10. They told me time. Oh. What's the time they told me? 5.2? How could I find dy? I'm looking for an equation that has Vy initial. That's not much of a y, Mr. Dueck. Yeah, let's fix that a little bit. A and t. Justice, which equation? Yeah, it's got the d by itself already. Good call. VIT plus a half AT squared. On a test, I would plug in the numbers, but I'm trying to do this all in one line desperately, so I'm going to go 10 times 5.2 plus 0.5 times negative 9.8 times 5.2 squared. Do you get 80.5? What's the negative telling me? We ended up below from where we started. Now, if I had said, find the vertical displacement, then, Logan, I'd be fussy and I'd say, tell me negative 80.5. I didn't say find the vertical displacement. What did I ask you to find? Height, which is technically a scalar. If you said the height was negative 80.5, I like this question, I like this question, I like this question. On the test, I wouldn't take marks off, but I'm a nerd, I'll do this right. 80.5 meters. B says find the range, dx. You know what? I would go dx equals vxt. Bada bing, bada boom. I'm actually going to cross out B, and I'm going to jump straight to C. C. Kyle, what's C asking me to find? Don't tell me 0. That's Captain Obvious. Yes, I know after it hits the ground, it comes to a stop. When I'm talking about a projectile and I talk about final velocity, what I really mean is the impact velocity. What would that look like based on this picture? I think I can make a reasonable assumption that it would look, if I draw a little picture, something like that. Rachel, do you notice what I drew is at a slanty angle? Any thoughts on what I should do now? Did you say components, or were you yawning? Both. Components, where this is Vx, hey, which I know, 17.32. And this is Vy final, which I don't know. Mr. Dueck, this is just like the question we did a few minutes ago. Yep. Like I said, Emma, as far as I'm concerned, anytime I can ask you to find a slanty velocity, if you know the time, you're good to go. And they did give us the time at impact, 5.2 seconds. If they hadn't, could we find the time at impact? Yeah. But it's a little nicer. So over here, I'm going to say AY is negative 9.8. Vy initial is 10. T is 5.2. What's Vy final? Well, that's going to be V initial plus AT. It's going to be V initial 10 plus negative 9.8 times 5.2. Vy final ends up being 10 plus negative 9.8 times 5.2. 40 point, oh, negative. What's the negative telling me? That when it hits the ground, which way is it traveling vertically? Down. Negative 40.96. Mr. Dueck, can we round that off to 41? No, because I'm using this to find a better value. Why would I round off now and introduce error? I'll round off at the end whenever it's a final answer. I ditched the negative in my drawing. Why? Because the arrow pointing down implies negative. Now what? How can I find the impact velocity, the final velocity? Good. Try the Pythagoras and the SOHCAHTOA on your own. Let's see if we get to the same spot. I'll freeze the screen. I'll unfreeze it when I'm done. And don't forget to add a direction, a theta. Yeah? No, yeah? Okay. Let's kick it up a notch. How many got that okay? If you got that, I mean, that's a challenging question. Okay? There's only one way to make it tougher. Instead of hitting the ground, hitting a wall. Skip example 4. Example 5. Hitting a wall. All right, let's plan our attack. So it says, with what final velocity, magnitude, and direction, which means it's going to be the same kind of an idea. We're going to draw, we're going to dulp a slanty velocity. Since it's slanty, we're going to find some components. Probably we'll be able to get Vx fairly easily. Probably Vy is going to be a bit more of a challenge. Okay. And I'm going to trust that the picture is accurate, that it's hitting the wall on the way down. So when I draw my picture, I'll draw it slanty down. What have they given me? Are we launching from a cliff? Okay, ground. Straight or at an angle? Okay, that should at least allow me to start. What would I do first? Components. So let's break this up into Vx, Vy initial, Vx is going to be 26 cos 37. Vy is going to be, Vy is sine. I get for Vx 20.765. And for Vy, I get 15.647. Okay. If I dulp, yump, there's my velocity. Looking at right here. So I kind of figure this is that. Is that okay, Ashley? Which I guess I'm going to break up into Vx, which is 20.765, and Vy final. Oh, I like this question. I like this question. I like this question. Did I say that already? I should have. Most common mistake I frequently see, kids do this. Don't write this down. And then they do the Pythagoras. And you know what they get? 26. And then they do the trig. And you know what they get? 37 degrees. They don't realize they've just put the components back together. And they're all proud. Because, in fact, often it works out like almost evenly. And they're like, wow, this is great. You know, I must be doing this right. No. Final. Vertical. All right. Over here, let's go vertical. I know AY is negative 9.8. I know VY initial is 15.647. Rats. Do I know vertically anything else? Do I know the vertical distance when it hits the wall, how high it is? No. What have they told me in the diagram that I haven't used yet? A horizontal. You know what? Okay, then. Horizontal. AX is 0. VX is 20.765. They gave me DX, which is 40. What can I find with that then I can swap over to the vertical column? Time. Ashley says it's about time we found time. Okay. I'm looking for an equation that's got A, Vx, dx, and t in it. Yeah.
T equals dx over dx.
Ooh. He did 2 steps at once. You impressed me. Atla, you impressed. Hang on. Hang on. There we go. You impressed me. There's daylight. Okay. First of all, he in his head said it's going to be dx equals vxt plus a half a. Oh no, he crossed out the half at squared over horizontal. And then he said, hey, I can get the t by itself already. T is going to be distance divided by velocity. Horizontal, horizontal. It's going to be 40 divided by 20.765. It's going to be 40 divided by 20.765. 1.926 seconds. Both vertically and horizontally, that's time of flight. It's just a little different tie because this time, instead of hitting the ground, you got interrupted by a wall. But that's okay. The physics still has to work. Ben, I'm looking for an equation that's got VF, T, VI, and A in it. Any thoughts? What equation am I looking for? Or did you already go ahead and finish? Maybe you already went, I think you're already giving it to me. So I think you went like this. Vy final equals Vy initial plus Ayt. Is that what you're saying I should do? Say yes. Nice. And then you're going to go Vy final equals 15.647 plus negative 9.8 times 1.926. You're saying negative 3.231? 3.231, is that what it was? Vy final equals negative 3.231. How's that help? Yeah. Yep, quick look, bunny. And I'm almost done here too, folks. Now what? Pythagoras and trig. V is going to be that number squared plus 20.765 squared equals square root equals 21 meters per second at tan theta equals opposite over adjacent opposite 3.231 31 Mr. Dueck over 20.765 and lo and behold 8.8 degrees. This time above the horizontal or below the horizontal? Marissa, that's about as tough as I can throw at you. That's combining a little bit of everything. Well, you know, actually that's a fib. The only way I could make this tougher, and I won't, is instead of giving you the horizontal range, I could have given you how high it hit up on the wall, because then you would have had to pull out the quadratic equation to find t, because the VI wouldn't have, you would have been using d equals VI, and bleh. I say again, bleh. But it's doable. What's your homework? Oh, comic from Foxtrot. Again, what I like, if you'll notice, the physics is correct, although he's using g equals 10 instead of negative 9.8, which I guess is acceptable, but the physics here is correct. The doodling is correct as well. Your homework really is two things. First of all, complete the ultimate kinematics review. This is due on the day of your test, which right now is probably going to be a week, Wednesday. So a week from Wednesday. That's what I'm tempted to. I know it's after a long weekend. That's what I got. I'll probably be doing a tutorial Friday after school, but I'm also going to email out my video tutorials that I've done, summaries from previous years. So if you haven't yet signed up on my email list, you're missing out, because sometime tonight I'll probably send you an email with the list of all my tutorials from previous years if you want to see lovely summaries. But more importantly, Due next class. Take home quiz. Oh, Carly rolls her eyes.